Okay, so I've already got my permanganate in there. And the fan is on. So I'm just going to add a bit of concentrated hydrochloric acid. And then using this funnel, tap funnel, I can drop that in. Pop the lid down, and almost immediately the HCl is reacting with the permanganate. It's bubbling a little bit. It's quite hard to see that. What you might be able to see is slightly greenish gas starting to form in there, and then we just need to wait for that gas to make its way into the gas jar. Okay, it's just beginning to start there. So we've got pale green or yellowy green gas starting to appear in the gas jar there. So we can't do many reactions on with chlorine. The one that we are able to do is with iron filings. So while that chlorine is so I've got iron filings here and a spoon. What's the what's that brown smoke we can see there? Not many options. You need a number in there. Yeah, it's 3 actually, because chlorine is a strong oxidizing agent, so it would take the iron to 2+ and then all the way to 3+. Yes. So yeah, it's FeCl3, which just needs a little bit of balancing. Just balance that for me, thank you. Just dissolve that in a bit of water. we get a lovely kind of golden coloured solution of iron 3 chloride. Got a balancing?
Yep. 2 for the iron, then 3, then 2 again.
Lovely. Thank you. That's that. Bringing. Bromine is kept in a special container. I mean, the bromine bottle is kept in a special container. What am I looking for? Just going to use a bit of Vaseline on the thing there. It just seals it in tight. We don't want any bromine getting out. Thanks. And then I need the big gloves for the bromine bottle. Very carefully take just literally a few drops. There we go. We've got the distinctive red liquid. I don't know how well you can see it, but it's kind of blood sort of coloured liquid, thick dark red liquid in the bottom, but just enough heat in the room to evaporate that, turn it into the, well, the colour of the gas goes down variously as red, orange, brown. Don't know what you see. Colour subjective. I would call that orange. We can't do any experiments on bromine. It's too dangerous. We just get to look at it. So enjoy looking at the bromine. If I spilt a teaspoon, really half a teaspoon of bromine in the lab on the floor, we'd have to evacuate the room and call the fire brigade to clean it up. Very, very toxic, very unpleasant compound. They will come in with full breathing apparatus. So, with that in mind, oh, I do have one already. With that in mind, I'm going to get rid of it. So that's thiosulfate, reacts with the bromine. You can see distinctive sort of cloudy appearance. Remember the disappearing cross? It's the same reaction. We're getting a bit of sulfur there. Do you want to leave that in the bottom, or do you want to take it?
I'll take it because I need to change the.
It looks like there is still a bit of bromine down there somewhere. But sit in the bottom of your fume cupboard. Okay, so that was bromine. Hope you enjoyed that. The last halogen we're going to look at is the iodine. good. There we go. So if I put a little bit of heat under the iodine, doesn't take a huge amount before it starts to evaporate. So the iodine has quite a low melting point and then fairly low boiling point. Just above that, so it very quickly turns from a solid to a gas, and we get this very lovely distinctive purple vapor. So all the halogens have coloured gases. Fluorine, which we'll watch on video, we're not allowed to show you fluorine, but fluorine's a very, very pale yellow, and then chlorine is that greeny yellow. Iodine, the purple, and bromine we saw was that orangey brown. Again, we can't do any chemistry on the iodine. But we can do some on iodine solution. Letting it cool a little bit, so the aim of the watch glass with the ice on it is so not too much of the vapor escapes. So it hits the watch glass and turns back into solid. That's what we're going for there. Bottle there. Yeah. Could you just grab some thighs off it? Okay, so if I put a bit of water in there, you might be able to see not much happens. That's because iodine is very soluble in water. We haven't talked about solubility much, but the rule for solubility is things dissolve in something that's like them. So water, of course, it's a polar molecule, and it hydrogen bonds. So it dissolves things very well that are also polar and also hydrogen bond, like alcohol. Alcohol and water mix almost perfectly. Salts have charges, so they work well with the charges on the water there. But iodine, it's a non-polar molecule. How do iodine molecules stick to other iodine molecules? Hey? No, how do iodine molecules stick to other iodine molecules? Van der Waals forces, okay. But Van der Waals forces and hydrogen bonding don't really get on. So that's why iodine doesn't dissolve very well in water. So the iodine solution that you often use, we're going to use later in biology lessons, to test for starch, that kind of thing. It actually has some potassium iodide in it, and you can see immediately as soon as I drop that in, the solution starts to change colour. Now the iodine's dissolving nicely, so that the iodine actually reacts with the iodide to form the I3 minus ion. That's the orangey brown solution that we're all familiar with from biology labs. The triiodide ion. And there's an equilibrium between the triiodide and the iodine, and I can prove that with a test tube. So I'll take a little bit of the iodine solution. Substances like iodine. So if I add a little bit of that to the iodine solution, so first of all you might be able to see we get two layers. If I just give that a shake though, start to see the dichloromethane layer on the bottom there has taken the lion's share of the iodine. So what's happened is the I2 has dissolved in the dichloromethane, and that's pushed the equilibrium to the left, using up the triiodide, which was the brown solution. Remember, the solution used to be that colour, now it's a much paler yellow, as the iodine preferentially dissolves in the dichloromethane. One last thing. So we talked about the colour of iodine. So students, when asked what colour is iodine, will often say, "Oh, it's brown," because they remember it from biology. Iodine is not brown. Triiodide is brown. Iodine is, wherever it was, little grey solid, or it's a purple vapour, or it's a pink solution. Rose colour. One thing it is brown. that's it?
Yeah.
That's everything. Okay, right, we'll leave that there.